All right, so welcome everybody. Thank you for joining us for our professional development session. This session is going to be presented by Arizona State University's Center for Broadening Participation in STEM, as well as Nanotechnology Collaborative Infrastructure Southwest. And so we do have our presenters that are with us this morning. This afternoon. And so first of all, I would just like to do a quick introduction for AIEA, if you'll just bear with me just a couple of minutes. So Nawakwa Hatso and Toya Goigu Masip Chawi Aimda Kimberly Denko Khan. My name is Kimberly Denko I am of the Kiowa Caddo and Pawnee Nations, originally from Oklahoma. I currently work with Amphitheater Public Schools as Native American Education Coordinator here in Tucson, Arizona, and I currently sit as the president for the AIEA. And so I just want to say welcome everybody. Thank you so much for joining us this afternoon. We have a great presentation for our professional development, and we look forward to the presentation that will be held here. And so at this time, I am going to turn it over to Ms. Anna to share and start your presentation. So you should have sharing capabilities.
Okay, great. Thank you. I am going to share my screen. Again, my name is Anna, and I do have my colleague here, Jessica, and we are from the NCI Southwest, the Nanotechnology Center. So thank you very much for joining us today. We're going to have an exciting event. So here's our information, our photos, our email addresses, if you ever need to get a hold of us. And also, if you also need more information in regards to some outreach, club events, after school events, please feel free to reach out to us. Keep in mind that all the information that we will be providing is recorded, as you could see. And then also, if we needed to do any type, I just want to put this disclaimer, remote session, it is free for your school.
Awesome. Awesome.
Yeah. So here are today's objectives. We are going to look at the mimicking of nature. What has engineers and scientists do to mimic nature and to help humans solve their problems? We'll look at nature to nano. We'll look at the understanding of that. We'll look at the nanometers, the size of it, what's in place for that. And then we'll also go into nanotechnology. So throughout the history, architects and designers have always looked at nature for inspiration. Researchers have also found strategic strategies or logics that will help with nature process and growth and evolution. So as organs are adapting to the geosystem, researchers have learned from this. They've learned of what organisms are doing and how they're adapting to the ecosystem on our Earth. So biomimicry is frequently used in scientific research to explore common connections and structures with the biological field of science. It's always used. So what is biomimicry? So here we have some information about what is biomimicry. It's a study of nature's best ideas of imitating and solving human problems. Biomimicry is a study of how nature can be a primary source of solutions for our own problems. So we have a lot of global water issues that we need to really look at nature and our own community to help us solve that. And biomimicry also suggests that studies of nature's has best ideas they've adapted, and we want to learn that adaptation, and we want to also take that and be able to solve, like we said here, human problems. So we want to be able to now consider what nature is teaching us so we're able to sustain Earth. It's very important that we do that in our community. So here I'm showing a few photos. As you can see, the leaf, there was some biomimicry that was designed for solar panels, as leaves are solar panels absorb the sun and they turn it into energy. The engineer really looked at the leaf and looked at in the 1981s, they looked at that and kind of took the idea of the design of the leaf to design the solar panels. It's interesting because I didn't know that until I did the research and found out how the solar panels were designed. Um, a big bonus factor is that one plant is really particularly absorbs the energy to make a great efficiency, and they also are able to absorb that energy and keep it there for decades. So it's very important how we use solar panels and how we're able to produce these solar panels frequently. And we're here in Arizona, so we have a lot of solar panels that we use for the sun and to produce and to help us with so much. The other photo here, as you could see, that we have, you see a bullet train, right? Does everyone see a bullet train there? Yeah. Okay. So the bullet train was also something of a biomimicry that was done by the kingfish bird. The peak of the kingfish bird was really taken from one of the engineers, how it's really sleek. And also for the kingfish bird, how quickly they are, but how quiet they arrive to their landing space. So those ideas, those biomimicry ideas, an engineer took from that and designed this bullet train that was in China. And it's very important. So when you're on this bullet train, it goes very quickly, but it's so quiet that these ideas were taken from the kingfish bird. It's a beautiful bird. It's a very sleek, very quiet when it arrives. And it's important that the bullet train also does the same thing. And when it arrives in a tunnel, it's very quiet and eliminates any issue or pressure when it goes into the tunnel, this bullet train. The other one is the umbrella. So as you see here, there was some biomimicry that was used from the design of the tree. So from the design of the tree to the umbrella, that overarching look is very important. And I don't know, have you ever been in the rain and went under a tree and you don't get somewhat of soaking wet, but you do get a little bit of drizzle. And so that cover of the biomimicry was very important to design for the umbrella. So these are just simple, small photos that I wanted to share about what biomimicry is and how nature is utilized, and how it's very important to really, when looking at nature, how can we look at the structure, the process, the models that they take when when they're in the ecosystem, and how it's adapted, and how humans can take that and apply it for solving our problems. So I'll go to the next slide. So we have an activity. I wanted to do an activity with everyone here on Zoom. I don't know if it's possible or not. So when using biomimicry in the nature world, organisms have different characteristics, and these characteristics appear in behavior, in structures, in patterns, and materials. And so as you can see a flamingo that's there in our photo. So I do ask that we do this activity. So everyone get out their cell phone. And in your cell phone, you have a timer, right? Set your timer for 20 minutes. And as you see here, we'll go back to the flamingo. You see the flamingo standing on one leg. And the purpose of that is flamingos can stand on one leg for 20 minutes or more. So can we do some investigation work? How long can we stand on one leg take the time. It says have a partner with you, but because we're on Zoom, I don't know if some of you would like to open up your screen or video and start your timer on your phone and see if you can stand on one leg more for 20 minutes or maybe less, maybe 10 minutes. But how can we as humans adapt to this? As we see the flamingo, what can we use on standing on one leg for other activities, for other human solutions, and how can we adapt to that? So I don't know if we have anyone on Zoom that would like to try it. Any activities? Kimberly? Would you like to try?
Sure, I can stand up and for 20 minutes. Let me.
Or you could do it for 10. I know the flamingo can stand on one leg for 20 minutes, but if we did it for 10 minutes, how can we as humans be able to adapt to this? The question to you is, what would be the comparison? I know that if we did 10 minutes instead of 20, we can't do a comparison with the flamingo, but how can we be able to utilize this pattern that we're showing you that the flamingo can do, that we can do? Like, what other things can we do to apply it to solutions for humans and sustainability per se? So Kimberly, why don't you just try it for 20 minutes and then maybe I'll pose some questions to you.
Okay, sounds good.
Anyone else want to do this?
Kimberly, I'm going to try it too while I'm presenting. I'll let you know how that goes. I got my timer started. We'll see.
So go ahead and get started. And did you start your timer?
Let's see, for 10 or 20 minutes.
Try for 20 minutes and see.
Okay. So just holding my leg up without using any.
Yeah, just
okay.
Hold on, and I'll do it too. But think about and you can start your timer too.
Okay.
Think about the solutions of what we can do and how organisms can apply on solving problems with in an architectural design, in a structure problem, or in human problems that we might need. So this is how flamingos really adapted to get food, drink water. How did they adapt to this? And so can we be able to mimic some of the things that the flamingo is doing? So what time do we have right now?
Just a few seconds. I'm still at 19, 15, 14, 13. I started it, so.
Good. How are you feeling?
I'm nervous. Because I don't know if I can stand on it for the entirety, because I can already feel the tingles, but
well, I don't want you to pass out though.
Okay. No, I mean not just all over, just in my leg area, because I'm not used to standing up for so long. I mean, I am, but I'm not, especially on one leg. But on the questions that you pose forth on, them, this is how they live and survive on getting the food and things.
Yeah.
For me, it's difficult because, of course, we're used to standing on two legs and doing things with two, so having just one and trying to do things or even think about it, I'm a little nervous.
Yeah. And that was that's the reason for the exercise is really think about how our behavior has changed. We're still thinking that as humans, we still have our other leg. Even the flamingo does too, but they really use just one leg to get their food, to get their water. And, throughout nature is important for us to understand how they adapted to that so quickly. So I don't know if where we are, maybe at 10 minutes or so forth.
Yeah.
Yeah. And you could stop. You could stop there if you like. Jessica, you can too.
I'm going to try it. I'm going to try to present a little bit, but we can come back. Kimberly,
Yeah.
I don't see you shaking at all. I'm like wobbling all over the place and you are stationary. I'm impressed already.
Well, I've had to do this type of exercise before, but you're probably not seeing the lower part of me, but I am, kind of my legs just kind of going like this back
Yeah.
to maintain balance. And that's what I'm saying with, I can't imagine the flamingos because they have a top heavy, that
Yeah.
and
Yeah.
trying to maintain on one leg. And so I guess cheerleading in high school actually helped me because I've had to, learn how to use my legs to stand straight, as I'm up in the air. So that's probably an advantage that I have on doing this type of activity. But my gosh, it's been, I'm not even going to say how many years ago that was, but, just coming back on how to maintain.
Yeah.
that.
So,
Yeah.
it's interesting. Everything that you shared with us, engineers, scientists would take down notes, research all of that, and understand how can they build something from looking at the flamingo and their adaptivity to the environment, and how can that be applied to humans, and what can we do to learn from that. Even though sometimes, us humans, we understand in our brain, we register in our brain that we have the other leg, even probably a flamingo, but what can we do to learn from the flamingo to apply other skills and ability? And that's what biomimicry does, is the researchers, engineers, architects really look at everything in regards to nature, and what it offers. So thank you both for doing the activity. I appreciate that.
Yeah. Thank you.
So the biomimicry approach shows how problems can be solved by revisiting and by observing nature and organisms' performance. So like we saw, it's very important. So if we see here, let's explore the blue morpho butterfly. The unique, what's unique about this butterfly in nature is iridescent wings that you see here. Isn't it so beautiful? Yeah. So what is iridescent? Iridescent is a color change. Look at and see how the butterfly's wings are depending on the angle in which you see and look at the surface. It's like it's different. So we will see, I think, do we have a butterfly that we're showing, Jessica?
We have in our simulation, we have the butterfly, and then on our SEM, we have another specimen. I'm not going to give it away because they're going to guess on what it is.
Okay. So, to integrate the biomimicry and nanotechnology field, this will allow that the architecture is possible for collaboration between different fields of science. And so they look at, they analyze and create structures, engineers design and solve using the structure. So it's very important that the engineers, the scientists come together, they review so much stuff, they review the data, the research to solve problems and look at like simulation and analyze. It's very important. And so I think at this time, I will turn it over to Jessica to continue on and to guide us through and explore the nanotechnology. And I'll be her slide.
Thank you, Anna. Thank you. So I'm on two cameras here because at a certain point, I'm going to be sharing my screen and we're going to have another courageous volunteer take over control of a microscope. I am in a lab right now on ASU's campus, and Anna and I thought it might be important for you to show how we can, some different lessons and different ways that we can connect students to both biomimicry and nanotechnology. So as Anna mentioned, the blue morpho butterfly, what's interesting about the butterfly and the iridescence is that even companies, so scientists will research, engineers will design, but even companies will have their research and development team use biomimicry to solve problems for products. And the blue morpho butterfly, because of its iridescence, even tech companies like Qualcomm, they use this butterfly, and they use the skill of biomimicry and the science of biomimicry to create an e-screen that mimics that same iridescence. And the screen actually gets brighter with sunlight. So if you have an app that allows your screen to adjust brightness based on the light in your space, probably that originally came from some research of insects that have an iridescent, or even peacocks. Peacock feathers definitely have an iridescent feature to them. And so now we're also going to look at, how do we know, and you can go to the next slide. Yes, perfect. What is nanotechnology, and how do we know, how can we see the structure of something like our blue morpho butterfly to understand that structure when the feature that we're looking for, and in fact, the feature that gives the butterfly its iridescent effect, is so small that we can't see it with our eyes. And this is a really the cool part about nanotechnology and some of the outreach we do here at ASU is to help students. We've gone to presentations as low as maybe 3rd grade to help them see and help them understand science, chemistry, physics that we can't see with our naked eye. And so on this slide, what we're really trying to do is kind of introduce how small is nanoscale. So that scale bar there where you see the tennis ball and a period and a cancer cell, that's showing you, if your tennis ball is at 100 million times our scale, our nanometer scale, then we see our cancer cell is still between that 10,000 and 100,000. And if we get all the way down to nanometer, that's where our 1 is. You're really looking at like a glucose molecule, or glucose molecule. So it's really pretty tiny. An oxygen model, let's say, is about 5.5 nanometers in diameter. So the nanoscale deals with dimensions between about 1 and 100 nanometers. It's a billionth, or 10 to the -9th of a meter. Naturally occurring nano materials exist throughout nature, throughout our environment, even viruses like you see on this scale here, bacteria, water droplets, cells. But in addition, we humans produce nanomaterials, and sometimes they can be a byproduct of human activity that might be concerning to our health, such as bus or automobile exhaust, car exhaust, or welding fumes. But they can also be very helpful to human health. So sunscreen is an example. Titanium dioxide nanoparticles are actually what's in our sunscreen to help protect our skin against UV radiation. Also, silver nanoparticles kill bacteria. So sometimes scientists put silver at the nanoparticle level into a substance to help, especially in the medical field, ward off bacteria. You can go to the next slide, Anna. So how do we see? And that's really where this is just one example of a nanotechnology lesson. And Anna and I are going to show you at the end of our presentation, there's a plethora of resources. We're going to show you some of our favorite sites to share with teachers on how to bring nanotechnology lessons into the classroom. In particular, today, we want to help you be able to see, and we want to show you how we show students how to see all the way down to the nanoscale. In engineering and materials science, we have to use tools, and most students are familiar with a light microscope. And so we use that sometimes as a starting point. Light can help us using a microscope see a material, but maybe only up to 1,500 times. So 1,500x you might see on your light microscope. Well, in nanoscale, because we want to see the material that we want to see, for example, DNA or a virus or a bacteria or human hair, is so small, we have to use a completely different type of science. And nanoscience and nanotechnology relies on what we call different instruments. And the one we're going to show you today is a scanning electron microscope. And what that is, it's a tool, and you can see the comparison on this slide here. It still uses a lens. It still uses a source, although instead of a light source, now we're using an electron source. And it still uses a beam, but instead of a light beam, we're using an electron beam. And the SEM will basically use those electrons to create an image of a surface of the material. So you load, and we'll show you that in a little bit today, you load a sample into an SEM, and it helps create an image for students to see, where you can zoom in all the way down to the nanometer scale. To image that object, your electron gun, which is at the top, it's not a real gun. Kind of think of it as, I always tell students, like a water gun. So anything that shoots something, water guns shoot water, an electron gun shoots electrons. And it pushes that beam of electron through a chamber, through condensing lenses, and the electrons excite each other. What's great about going through this whole exercise with students is sometimes physics can be really difficult to understand. And so when you give them a tool that uses some of the physics concepts that we talk about in our schools, it can help them understand magnetism. It can help them understand some of these concepts. And even as far as electrons moving out of orbits. And then we have electron detectors that measure those electrons that are moving out of orbit, and we are able to create images onto a computer screen. And this technology, it's not super new. It's been around since 50s and 60s, 1950s and 60s, became really popular in research. And now, in fact, electron microscopy and some other tools, like I mentioned, they're the backbone of how we are able to create semiconductors. All the technology in our phones, the solar panels, like Anna mentioned, a lot of that is very dependent on, can we see at the nanoscale? And if yes, then we start building technology that allows us to create devices down at the nanoscale. And most of that relies on chemistry. So it's also a great way to tie in with students, why is it important to understand elements in chemistry? All of that is really critical in our technology dependent society where we are now. Go to the next slide. Before I go into this slide, I would like to pause though. I know that's a lot of science and background in a real short period of time. So if anyone has a question about what I have said so far, I would be happy, and I'm going to pull up the chat too so I can see it. Or Anna, check in too. If there's anyone that's got a question, you can type it in the chat or ask away.
No, just Kimberly and her leg was tingly.
Okay, no problem.
All right, go.
I'm gonna keep going then. Okay, so let's bring this back then a little bit to our butterfly. So we know that the blue morpho butterfly has iridescence, but how can we use that? Aside, for example, of Qualcomm and how they made their screen that's able to dim based on sunlight, we also, scientists and engineers have used iridescence to create an emblem or something like on your passport or your credit card, or even our money currency has a seal or an emblem that has iridescence. So it can be used as a way for fraud protection to ensure that you don't have fake money and that your passport is real and your driver's license is valid. So what we would like to do next is, yes, we are going to have an activity. And we do need a volunteer. And Kimberly, I don't want to pick on you. Is there anyone else online that would be interested? And I can't quite see if we have other participants. Is there anyone else that would be interested in volunteering?
Depends. What is it?
Okay, this one is not a physical activity. What I'm actually going to have you do is I am going to, now this will take me just a second, but I'm going to have you take over control of you're going to share your screen and you're going to go to this website and I'm going to talk you through this activity a little bit. It's called, and this is the first time Anna and I have done it this way. So we're hoping it works. If not, I will just take control back over. You want to go to,
Do I stop sharing?
yes, nanoforme.org/butterfly, that link. I'm going to show you what it looks like.
Can you type that link in the chat?
Oh, yes, great idea. And in fact, everyone that's online, you could pull it up if you'd like. This is an example of an activity that, again, teachers can use in the classroom. It's going to go over the basics of, because I know Anna and I've explained a lot of, we've thrown out a lot of terms in science. And I am a teacher, classroom teacher. I've been a teacher for about 20 years in the Phoenix area. And I've attended many different PD sessions. And a lot of times I loved them. And I thought, how comfortable am I going to go up in front of my students and introduce these? It's not an easy thing to do with science and technology. So this great website has created a lot of hands-on engaging activities specifically related to nanotechnology. And this particular one is a bit of nanotechnology and biomimicry. And it can be completely student guided, student led. It's an activity that a teacher could pull up on devices or in small groups. And students can actually explore a little bit about microscopy, about scanning electron microscopes and nanotechnology.
So
how are we doing?
Leanne, share her screen.
Do you want to try it? Are we able to get to the link, Leanne?
Oh, I was going to see if Katie wanted to do it first. Katie, you interested?
Come on, Katie.
You can go ahead and try. My internet is really spotty here.
Okay. So you want to, let me turn on my camera. Give me a second. Okay, you want me to share my screen?
Yes.
Try the link first. Are you able to get to the link?
I'm in the link. Yeah.
Okay.
So let me see here. Okay, there you go. Should be coming up.
Excellent. Okay. I'm going to pause for a minute and you're going to go ahead and hit play.
Okay.
Excellent. Good. So it might be tricky with audio with our screens and such, but this is our scientist and she would be a virtual version of Anna and I taking students through, as you can see, she is in a lab space, very similar actually to the one that I am in right now. On that back left, you can see that is actually a simulation of an SEM. Yep. That might be the light microscope, actually. I think that's a light microscope, and on the right is going to be the SEM, but we don't have to guess that. This activity will guide the teacher as in a full class presentation or the students through a little bit about light microscopes, electron microscopes, how they're different, how they can be used, what nanotechnology is. And in fact, if you see, there's a butterfly on our screen. It even uses the butterfly as an example, and I believe it mentions iridescence as well. So it's between the PowerPoint presentation that Anna and I have created today and this resource, we feel those are two great introductions for teachers if they have interest in bringing the ideas of biomimicry or nanotechnology into the classroom. As Anna and I have mentioned on our slides, we do have a lot of different resources. There are quite a few, all of them free, quite a few resources available for teachers. Now, what you're doing now, Leanne, am I saying that correctly, Leanne?
Linan?
Linan,
Oh,
thank you.
Linan.
Yes. If you clicked on the butterfly, start with that first box there, bottom left corner. Yep. and you see 3 centimeters. And what this screen is telling you, that eye there is saying you, okay, if you can visually see the butterfly, you can see about 3 centimeters size materials, but not much smaller than that. And this video will kind of walk you through a little bit about it. And then I think, can you click on the next box yet? Yep. Now what we're going to do is you start to zoom in, just like you would have an optical microscope. So if you don't have an optical, or the teacher doesn't have an optical microscope with them, you can still students start to get to sense, okay, now, and this is great for math, because a lot of times we talk about size and scale, but it can be a difficult concept for students to really understand. So now we see 200 micrometers, and that's about the extent of what you can see at 200 micrometers. And this, if you look on the left, that's an optical microscope. So using light, we can see about 200 micrometers. Now, if you click to the next box, we start going into the depth that we can see with a scanning electron microscope. And here we're about 4 micrometers. That's the distance between, that's our scale right there, 4 micrometers. Still looking at the butterfly wing, and you can start to see some of the structures. And if you try clicking, yep, right here, there should be some pop-ups with text. Yes, and each one of these stages, we won't read through all this, but you can start, there's text there that the teacher could read, or older students could read out loud, talking about resolution, how your electron microscope works, facts to explore, talking about the wavelength of light, and it ties it all back into that butterfly concept. You can close out of that box. And there's actually one more step even farther. The SEM that we will show you today is not the end all be all. There's actually atomic force microscopy, and there are quite a few other tools that can allow you to see even smaller resolution, all the way down to what is called the angstrom, which is even smaller than our nanometer scale. Angstrom is what scientists use if they really want to see an actual, an atom, if you want to see an atom. So this activity is really great to help with vocabulary building, for size and scale, to understand high-tech understand a little bit about high-tech equipment, and to introduce both biomimicry and nanotechnology. And if you click, there's questions there, you can click there, and there's more text. And also, if you, in each one of these, the 4 boxes, if you click on the tools, you'll get more information about your tool. And as I'll explain in a minute, we even do have the ability to do remote access. Some universities have an AFM, an atomic force microscope, and we'll show you how you can set up some remote access to those instruments. Any questions? I'm going to pause here.
Just as we were zooming in, I could see myself really squinting and moving forward just to see as if I could try and see it with my eyes. But that is really incredible, you know, and really tiny. So thank you for sharing that. Great tool.
Good. Yes. All right, then I'm going to go ahead and take over my screen. I'm going to share my screen. Actually, Anna, go back one more time. I think I have to show you one more thing before I take over and we do a remote access session. Is there one more slide? I think there's one more slide that shows what an SEM is. So that's the one resource. Nano for Me has an abundance of resources. That's one of my favorite. But Nano for Me also has curriculum for community colleges. The organization, or the grant, I should say, that I work under is NCI Southwest. We are Nanotechnology Collaborative Infrastructure Southwest. We are NAU, ASU, Maricopa Community Colleges, and universities throughout the Southwest, New Mexico. We are part of a larger national initiative that includes 16 different centers throughout the United States. The reason we exist is for a lot of reasons, for research and to support, but also because the National Science Foundation feels it's absolutely critical to engage the community in the work and research that we do, and to ensure that K-12 students have access to this, and teachers have access to the curriculum, and students have access to this knowledge. So we create presentations like this. We try to go out into the community and explain what we do, and then we offer our services free of charge, and an abundance of curriculum free of charge. What you see on this slide is what students might see if they would, let's say, go on a lab tour of a research room or field. For example, it's material science mostly, but engineers also have scanning electron microscopes in their lab spaces. And that is what we would say is a typical SEM right there. Let's go to the next slide. Now we're going to do what we call a remote access session. So what we have available is, we would love another volunteer. I'm going to start by taking over my screen, and that will allow me, I believe, I do have to admit, usually when we set up these sessions, I create the Zoom. By creating the Zoom, I'm able to transfer the control. So this is, we'll just test this out and see how it works. But what I'm going to do is start by sharing my screen.
I think Kimberly made you a co-host.
Excellent.
Yeah, I wanted to see if that'll help out.
Yeah, thank you. Okay, so I think you can see my screen now. And I'm going to give you a little overview, and then I'll ask for that volunteer. So what I have here is, and this is where my second camera. So to see my workspace, this is what we call a desktop SEM right here, scanning electron microscope. It's a fairly cost-effective tool. It's used mostly for outreach activities like this, though I am in a larger lab space behind me, full of researchers. This is my PI's lab, my principal investigator's lab. And this machine, though, I will tell you, costs about $200,000. So they are not cheap. It is not something that most school districts could afford, but we want to ensure that we provide access to a tool like this. The RAIN network, remote access for instruments in nanotechnology, is part of a national initiative where universities such as Arizona State University, we open up our equipment to K-12 and community college audience to ensure that if someone, a teacher, had a sample, they could mail a sample to us, or we could provide a sample for them and allow the students and teacher access to use the instrument. And I'm going to show you what it's capable of. So right now, what I have here is, I think you can see, let me do it this way. There you go. Now you can see my cursor. Okay. What you see right now is an optical image. So we have not, this particular microscope has both optical and electron capability. So we have not yet entered the electron world. And in fact, you can see we are only about at, can anyone see what's our magnification right now? Can you see on the screen? Can anyone see?
21.
Yep, we're about 21x. So 21 times, which is not too much. It's enlarged a bit, but we've enlarged our image 21 times. Based on what you can see so far, any guesses on what this might be? I might be able to get some guesses. Any idea what our sample might be?
Kit,
What was that, Katie?
a cricket.
Yes, very good. We've got a cricket. I don't have the name on it anywhere, do I? Just kidding.
No.
Yes, so we have a cricket. So we can image biological samples or material samples. We have microchips, we have crickets, we have some seashells, we have feathers, a lot of different images depending on what the teacher and students are interested in. And I always do give a disclaimer. We do not grow our own crickets and kill them and put them in the machines. You know, we're in a large building, and I could probably find some dead crickets in here right now. In fact, yep, right behind me. So we find bugs and we find samples throughout nature. And we, you know, microscopists, real microscopists, I'm a teacher, real microscopists have quite a collection. They create their own samples all the time based on things that they find. So no animal or insect had to give its life just for our demonstration today.
And Kimberly said that she saw an alien.
Ah, yes, it does look right. And it is a fun activity. We have a lot of images and I'll show you a few. Actually, let me just show you that right now. We have images stored on our microscope. Let's see if it lets it go over into it. Let's go over to our archive. We can sometimes start off a presentation by giving students or teachers a couple slides and asking students to guess, what do you think these things might be? There's all sorts of images. This is a good one right here that we might see in a little bit. This one. Let's see if I can. Yep, this one's a great one. But we could front load the presentation with all sorts of images for the teacher, and students can have a great time guessing what some of these samples might be. And we can customize presentations for classrooms based on, like I have a presentation at the end of October where their mascot is a bull. And so they requested a bullhorn. And sure enough, I reached out to the team here and someone has found a bullhorn and they're going to make a sample. They're going to slice a little sliver off and make a sample for us. So that would be fun and interesting. Again, biological and material samples. A lot of these are material samples because that's where most of the research is, and to develop new ways and layers for microchips. Let's see if there's any more interesting. Lots of just interesting samples. Okay. What I want to do now is, let me get us back to our live image, is show you how we go from an optical image to an electron image and what does that really look like. So I'm going to press this little button right here. Actually, I'd like to try to give control. I'm going to see if this works. Based on our Zoom that we have available, I'm going to see if I can give someone control. And Katie, you volunteered to do that. Was that right? I'm going to minimize here. And I'm going to try to, nope. Advanced, here we go, remote control. Katie Parker. I believe, whoops, you now have the ability to take control of the screen. You might have to accept it.
I don't think she's there.
Katie Parker is controlling my screen. All right.
Oh, she is there.
So what we've demonstrated is it sometimes, you know, especially in our classroom experience, we can't just stand up and talk. You know, students do love the hands-on. So we've created this opportunity for the teacher, and I'm going to do one thing. Katie, let me see if I can do this. I'm gonna make my, there we go.
I tried it, but it's not doing anything.
It's moving around. I'm gonna give you direction now. So now that you have control, what I want you to do is we're gonna recenter our sample. So try taking just one mouse click, yep, right in the middle of the cricket, where you imagine, right there, click there. All right, you've recentered our sample, which is good. Now we're still on optical mode. So if you go to the top right corner, you see the big circle, small circle, go right a little bit more. See where it goes with the crosshair in the middle, the circle with the cross in the center? You see where the circles are? There's two circles. Go to the right, farther on the outside of that box. Go farther right. See where the camera is? Do you see the camera icon? Keep going right. Right? Go right farther. Don't click anything yet. Go farther to your right. You see the camera? I'm looking. Can you see on? Yeah, I think so. See where the two circles are? Wait a minute. I think I can show you. Yeah, here. See this right here?
Oh, yes. Okay.
Yeah. You're going to click that button. And that is going to take us from optical mode to electron mode. And what we see now is, give it its time. You can't hear the buzzing that I hear. The machine's making a kind of reminds me of the old internet days where we had dial-up internet. Exactly what it sounds like. So it's processing. All right, and now we start to see our image. Again, we can put in any sample that a teacher is interested in. And now we have to, just like a light microscope, we have to make some magnification adjustments, and we need to do some focusing. And there's actually a couple other settings that we can change. So Katie, if you're comfortable, I'm going to give you some guidance and direction on how to clear up our image. The first thing I want you to do is if you move your cursor down, see where it says F and you see that's our fine focus. Keep going down a little bit more. Yeah, that's going to be our fine focus, which might do a little bit, but let's start with an auto focus. Let's go there. That's going to change our brightness. Yep. Click that button. Click it one more time. It's going to be our auto contrast and brightness. That helped a little bit, but let's go into focus. Go down one more and click our fine focus. It didn't do too much, did it? Let's take it off of fine focus. Try right click. Do you have a right click on your, yep, now click left click again. Now we're on, I think I went back to fine. Right click. And then just do a click of the mouse. The other thing you could do you happen to have a scroll wheel on your mouse?
No, it's a trackball.
That's okay. Go, let's do it manually then. Go up to see where that focus with the min max is, and there's that green line. Try clicking the green line. Nope, down a little bit more. Right in the middle. And it says min, M-I-N, and it says max. Yep. Try moving that. That should, if you go to max, you don't have to go all the way over, but just click over in that region and see if you can get the bar to move a little bit. I'm gonna try helping you out. Yeah, see, try click and drag. See, does it click and drag at all?
No.
Try clicking in the middle. When we set this up with teachers, we usually request ahead of time that teacher find. It just works a little better with a mouse with the scrolling like this, because then you can scroll back and forth. Let me try helping you out here. I may have to regain control in order to do that. Let me try, see where it says F down here. I put my mouse down here. Yeah, try clicking here. Yep, try clicking that button once. Now try going back to the magnification and see if you can. Click and drag or click in the middle. Click in the middle of the screen.
Yeah, no, it doesn't
Okay.
want to do anything.
Let me go back down here. See if you can give me control. Try to maybe stop sharing or release control. Maybe the mouse pad's not gonna let you move it.
It just has for me to share my screen, so I don't have any other options.
Here, let's do, let me try it that way. I'm gonna take back, I'm gonna share my screen again. Okay. Let me see if I got this. Okay, there we go. All right. I'm gonna do the demonstration then. And then usually what we do with classrooms is we actually schedule a tech check a technology tech with the teacher, and I set up the whole remote access, and we get the teacher to set up, and we kind of go through the basics so that the teacher feels comfortable when we have a session with students in the room. And I'll have to spend a little more time and try it with a trackpad. But I do know the mouse with the scroll wheel does work a little bit better. So what I'm going to do now is we're going to zoom in. And while we zoom in, I might pause here and we do an autofocus. And what we'll ask students to do is to check the magnification. I'm going to try a little bit of a different sample. I'm going to go over to a different part of my sample. Oh, here we go. All right, this is a little more interesting. Click my focus. And what I would do is I would ask students, okay, what magnification are we at right now? And ask them to describe, what do you see? Well, what do you think its purpose is? The cricket is interesting because the cricket hairs are also used in biomimicry. And then I would ask students to guess, what do you think might be some purposes of the cricket hair? Why would we study the hairs of a cricket? Anyone have any guesses? Let's hear, maybe type something in the chat. Take a guess. What do you think the purpose of cricket hairs might be, or why might scientists study cricket hair? Does anyone know what the cricket hairs do for the cricket? Let's start with that. Because I see a lot of hairs on this cricket. Brush hair is a good guess. Different noises is actually, so it's related to sound. Very good. So the crickets actually use the hairs and the vibration that they feel to estimate the distance away a predator might be. And so scientists have used this to help create experiences where they have sensitivities to different frequencies in a synthetic world. In sensors, let's say. So you might have a sensor for airflow or a sensor for like a hearing aid. Well, they try to understand and determine how the hairs can help all the way down to nanoscale, right? When we might see some hairs on a cricket, but most certainly we wouldn't necessarily see enough hairs on here, right? You think about a brush. These are pretty, there's a lot of hair on this particular section of the cricket. And so they might study that to figure out, well, how for a hearing aid, if they wanted to have a surface like hairs, how far apart would those hairs need to be? And in fact, in our tool, we can take students through measuring the distance between hairs, and we could set up a lesson. Again, as Anna and I said, there's a lot of lessons that are already made for teachers, including some that talk about crickets and cricket hairs. And how students could analyze a cricket's hair and use that application using tools like biomimicry or concepts like biomimicry to create some understanding. And the whole lesson plan is already created for teachers. So this is kind of an overview of how we could use remote access to an instrument like an electron microscope, how we could introduce a concept like biomimicry and help students and teachers explore some high-tech fields like nanotechnology. Again, we have samples specifically related to microchips, which is an area that National Science Foundation, and if anyone's tracking the news, we have the CHIPS Act, and locally here in Arizona, I expect we'll see a lot of attention and time and energy and dollars spent on K-12 education in order to create kind of an advanced manufacturing workforce. It's definitely an area where Intel is expanding, TSMC is creating an advanced manufacturing plant for microchips. And here in the United States, there is some concern about our supply chain and trying to create opportunities where we can manufacture the goods that we are now very dependent on in our technology-based world. So this is just one example of a presentation. You might have a biology teacher, you might have the students explore, what are they really interested in? My background's actually in environmental science and sustainability. So as Anna mentioned, trying to understand what some solutions might be, let's say for an oil spill. Is there a material that could be used in a sustainable way? As Anna mentioned, we have a lot of sustainability issues in our society, and there are lesson plans and curriculum to support teachers to teach these concepts using some high-tech tools so they can introduce some technology standards in a way that might be different than what they have access to on their campus. And this is one example of how we could do that and how we would like to support teachers in your community as they create opportunities for students to engage in technology and sustainable concepts in their classroom or after school or at a community event. And I just made that ending, Anna, but we might even have some slides left.
Yeah, I think Katie had a question because you got a hold.
Yes. Yeah. Do you work with the forensic side too, using this technology?
Yes, that's a great question. So the scanning electron microscope is one tool. We have, and I'm going to show you, let me show you that now, actually. I'm going to stop sharing the microscope screen, and I'm going to take you to a couple resources. They definitely, so forensics may need to image a bullet. We see this on TV. I've never seen it in real life, but my colleagues tell me about it. The police department does reach out to ASU from time to time, mostly with like a counterfeit kind of situation where they have something that they believe is counterfeit, and especially if they are creating a case where they believe certain individuals have produced a lot of counterfeit goods, they would definitely bring it to some of our labs, because not only can you do an image, but then you might be interested in the characterization, that chemistry, what is it made of, an elemental analysis. And so there are a variety of tools. This microscope is really just, there's some elemental ability. This one is not really set up to do elemental analysis, but we could introduce students and show images. And again, teachers can send in samples and we can do a full elemental analysis. We had a student, I believe it was a middle schooler, sent in a sample for their science fair project, and it was a salt sample, but they wanted to show the structure of table salt versus sea salt, or table salt versus sugar. Those are, ASU loves to support student-led projects. The oil spill example I mentioned, we have had some students for a high school science fair project. They wanted to biomimicry, they wanted to come up and they wanted to research, is it possible to use a nature-made material to help soak up some oil spills rather than using a chemical. Another example was a student that's interested in, plastics are a huge problem right now. Is there a biodegradable nature-made material that we could use rather than petroleum to create plastics? And this particular student was looking at fish scales. So you can imagine having some image and having some analysis of fish scales to see, what is it about their structure that can create a watertight layer where you could do something similar in the structure and use some fish scale like materials for plastics. For forensics, we have another tool here at ASU and it's a particle accelerator. It uses similar technology, but it's in a little bit of different way. And instead of a beam coming down and shooting electrons, they're shooting protons. And the particle accelerator is used, and you can actually, in this particular situation, I have to load my sample over here, and it's in a chamber. With the particle accelerator, you could take something like a piece of artwork. And in this case, it was a fraud case. Someone questioned and challenged whether a painting was authentic. And so with the particle accelerator, you don't have to cut out a piece of your painting. You can put the painting at the end of the machine, and you have everyone leave the room because there is some radiation, and the protons penetrate, though you won't see very much destruction. It's a non-destructive process, but they beat against the material, the painting, and they're able to gather all this information. And we tell students it's like billiards, and you're like shooting a cue ball against a ball, and you're scatter. That back scatter gives us information, and it can tell us, is there any difference in the age of the paint? And that's a true indication of a counterfeit painting, because typically someone has, years later gone in and tried to create a painting, or they've painted over a piece, they've done something, they've changed the painting in some way, or created completely different counterfeit painting. And scientists are able to date the age of the paint, and based on the elements that are in that paint, they have a lot of information, and they can pretty much, the Louvre in Paris, France has a particle accelerator in their basement, and they do this sort of thing all the time, and we have one here. They've also done the counterfeit analysis with, I want to say it was with gold as well. So whether it's purely gold or been plated with gold, we have tools that can help determine that. So definitely in forensics. That was kind of a long answer.
Thank you.
Yeah, when I took my biology class, we went down to the forensics lab, and I think that was when CSI and all, that was pretty popular. So I remember they showed us the centrifuge. We got to play with some of the magnetic fingerprint dust. So it was fun.
Yes, a lot of nanotechnology in that, right? And we have some labs. Some the ideas, we don't necessarily have the materials, but teachers, it's not too expensive to get some of that dust that they would use in a CSI experiment, where you can't see it, and then you get your black light out and kind of see where you've left a trace, or even using some synthetic blood and such. It's very engaging for students, and it's engaging for us. It's interesting to me what we can see and what we can image down at such a small scale, and how we can use it to solve problems and just understand what's around us.
Thank you. Thank
Yeah.
you, Jessica. Go ahead, Kimberly.
Okay, sorry. Just hearing this is really interesting. And just one fun fact, my son is actually, as I mentioned, he's in college, and he's actually in the environmental science major that he just started. He was in environmental studies the past 2 years and just switched this fall. So he's in environmental science. So all this would be really interesting to him. So I'm actually going to see him this weekend. So I'm going to share this information with him, what I've learned here, and it's really interesting. But I just wanted to comment that seeing what this type of science can do, I was wondering if you've thought about, and I know it's a bigger group, and as you mentioned, nationwide, but more narrowed, refined for Indigenous students. When, for example, the website that you showed, when the person comes up, if you could create something like that for the Indigenous students. And I just say this because of of course, what AIEA stands for, and our mission of improving that academic success for our Native American students. But when our students see somebody that they can relate to or see somebody that looks like us, it really brings that mindset that, oh, they understand, they know, about our community, or I can relate to them, even just by appearance only. So that's just a suggestion for, in future. I don't know if you guys have something like that already, but it's just something to think about, as well as the type of items or the and like I said, I'm a big sci-fi fan. So when I saw the image, my mind immediately went to the movie Alien and the creatures that are on there. That's what it looked like to me. But just utilizing the different I guess in nature for a lot of our Native American communities, like sage leaves or the cedar stems, or the tobacco that is grown in nature that is utilized for our people. But just certain items, or even a feather, an eagle feather, hawk feather, and narrowing it down and zooming in, that would be interesting for our students to learn and see, and still learn in this in this way about nanotechnology, what its uses for, and for our communities, of what those uses are for our people, and the reason why we utilize those specifically for medicinal uses, or even just cleansing, or within a daily task, day-to-day task for our communities. But it just has my mind thinking in that direction. Of course, that's the way my mind thinks anyway, but I think it's really interesting. And like I said, I'm really learning a lot. It's been a while since I've been in school. So, hearing about what this technology does and how you can really focus in and refine your research and what you're wanting to learn more about. And especially with the hairs, that was the first thing that came to mind with the cricket hairs, about the sound. And, I know that with bats, they use their ears, to hear the noises and the sounds and those vibrations, that come back. So I think that's really interesting. I never thought about that as far as crickets, but I know when I approach one, it gets really still, and really quiet, and then hops off. But that's just interesting. So I just want to say thank you for sharing that information, and just some things that come to mind as I'm sitting here listening and learning at the same time. So thank you so much for bringing that to our attention.
Well, thank you for bringing what you brought to our attention. That cultural responsiveness is very important for our Indigenous community. And we can do certain images for the community, for our Indigenous community, that if they bring the items, or they send the items to ASU, Jessica and our team would be able to do that. It would tie into a lot of the biomimicry too, because of the fact that if you're in the Indigenous land, having students be aware of how the environment, or how fertilizer or non-fertilizer can do harm to animals, to creatures, animals mainly, and how can we look at that in a sense in the microscope to help us ensure that the environment is more sustainable. So that's something to think about. I don't know, Jessica, do you wanted to add?
Yeah. So one of the reasons we were so excited to present to your audience in particular is because we recognize that we are deficient in our outreach and in our representation. So Anna's group is broadening participation in STEM, and she's very committed to ensuring that we broaden representation in STEM. So what we lack is subject matter experts, that representation, right, from the Native community. So we have a variety of ways, and I'm going to put on my marketing hat. We have a variety of ways that we would love to co-collaborate. The NNCI and the NCI Southwest, we host what we call research experience for teachers in the summertime, research experience for undergraduates in the summertime, and we're expanding that during the school year as well. And in fact, we could customize something if we had a member of your tribes or your group that was interested in co-collaborating and helping us create those opportunities. It's not essential. We can definitely work to create something and bring an opportunity based on some input, but it would be great if we had some representation in the curriculum and in the graphics for others to use and for us to use in these types of experiences. But I think at this point, it does take some co-collaboration to create those. So we have funds available and we would love to find someone that's interested. It could be a teacher, it could be some students, it could be just an educator. And maybe I can even create up a flyer of some sort. We would love to create that curriculum and that material that is representative of culture. Even as you mentioned, even just having the graphics represent someone that looks similar to the audience. We'd love to co-create that or find, and I'm sure I shouldn't say I'm sure, there is probably some, but it's probably very difficult to find. And even in the resources that we have suggested for teachers to use now, I'm not sure how well they're representative of the Native community. So even, yeah, I see Kim has, saguaros, prickly pear samples, exactly, even just having those samples. And typically when we do a remote experience, we do have a conversation with that technology check. We also talk about samples. And then again, I go back, I reach out to the microscopist here and I find custom samples. So that part isn't as difficult, but it would be really nice to have the lesson plans already speaking to things that students are familiar with and that are important to the culture of the audience.
Yeah, and we do have some experts here, Kimberly and Katie, that might be of interest to help with curriculum.
Just right off the top of my mind, I had a class where the teacher was talking about, wanting to do a really great lesson on dissecting owls. And it was just like, that's not something we do. And so they didn't know that, for us, it's just taboo. It's a bad omen, you don't bother that.
Yeah, exactly. Yeah. I think we were a little cautious about what samples, I'll just tell you, we were cautious about what samples we wanted to select for this group today. Yes, the owl is a no-no.
Yeah, definitely. I know just because I'm married, I'm originally from Oklahoma, but I'm married out this way to a Dene man or Navajo. And I know that for them, snakes also is a no-no for them. For my culture, it's bears. We can't, unless it's a part of our name or something that was handed down through the generations, I can't have anything on me that signifies anything about a bear, including a bear claw, a bear image, or anything associated with a bear. I cannot wear that because I do not have that ability or granted that ability to wear anything like that, unless it's a part of my name or a part of a name that my ancestors or my relatives gave to me. So that's, just little things like that that make a significant difference for our community that would really draw in the students. Even this drew me in because like I said, this is something interesting because I know my son's a part of it and that this is something he's going to be learning more about as well. But, just in wanting to help our community and our students academically succeed, we have to refine and rethink about how we collaborate and showcase these things to the audience. And so I'm really happy to hear that you guys are willing to collaborate, maybe not just with AIEA, but other Native American organizations, or even the larger organization, which is our National Indian Education Association. They have a lot of resources of curriculums that are available already on site, as well as the ACES group, which is the American Indian Science and Engineering Society, that provide a lot of resources specifically for the sciences, the science field. But I just think it's so interesting. And like I said, my mind's just really going and wheels are turning, and how we could make this a really great project specifically for our indigenous communities, because we don't have a whole lot out there, particularly for Arizona. That's one of the things that we're trying to work on a bigger level, to try and get culturally relevant curriculum implemented into the classroom, whether it's science or history or mathematics. Our people have been a part of all these aspects for many years, and since time immemorial. And so just bringing that into the forefront, specifically for, those communities, and even sharing out, because that's what we also do, is to help educate others about our culture and our way of life, to help them get a better understanding of who we are and the lands that we currently reside upon, and the respect that we give to them. And so, I don't think we can get saguaro print samples, but that's what comes to mind, just to be respectful of the lands and the homelands of where we're currently at. So in the area that I'm in, southern part of Arizona, and in Tucson area, I give respect to the Otham people and the Pasquayaki people, and for them, the saguaros are very sacred to them. And so something refined around the harvesting that they do during the summers with the prickly pears. So that's what came to my mind about sample wise, or the coyotes in the area, the hares, and samples of how you're doing with the cricket here, just different things that would really identify with those students, to where they could also learn from their perspective, and they can see, oh, well, now I understand why this is important, or oh, I didn't know that about the hairs on the cricket, or the hairs on the coyote, or the javelinas, or just anything that they can relate to. I think would really draw a big interest of wanting to learn more about it. In turn, it would really enhance their education and help them to academically succeed.
Yeah, that's excellent
Thank
feedback.
you.
Yeah.
We have to collaborate.
Yeah, and in fact, one other comment is, so not only do we have an education outreach interest, but we also have an interest in creating more opportunities and representation for startup companies, and I think we need to emphasize to students and Native American students that there may also be a lack of representation in materials. Do they have choices? Are there enough products that have been created and designed in a way that they feel is respectful? And even helping a class, we're really big on entrepreneurship and helping a class go through that process. Is there a product that you know of that you don't feel is respectful? Is there some way we can encourage, because we have research dollars as well, to create these opportunities for entrepreneurship for students? And I've told students, even if it doesn't make money now, we want to teach you that process and show you that there are resources available. So when you do decide to go to college, or you're out of high school, we have grants available to help a startup with this new idea. And I think ASU is very committed to broadening participation in not only STEM, but in entrepreneurship. So I would love to help get the right people in the room and figure out what a collaboration and co-collaboration might look like to support that.
That would be great. Do we have maybe any other questions, or maybe show the last slide of our resources, and then we can sign off if we want?
That would be great.
Okay. Jessica, are you still sharing your screen, or?
I think I am. And let me see, viewing, view options. I was trying that before. See, that's going to leave my meeting. See,
Oh, I can do it.
Anna,
I
okay,
can do
good.
it.
Good. Can you
Okay.
take back control? Okay.
Yeah. So this is just, if you can see my screen, a list of resources that we have. What I will do is I'll download these slides and send them over to you, Kimberly, and then you can share them with others in the organization, in the membership, So then they have access to this, but these have everything. They're,
We're,
yes,
we're
ma'am.
not able to see the resources. We still see the
Oop.
cricket.
You still see
Thank
the
you.
cricket. Oh, okay. The cricket.
Let me
Oh,
close
okay.
out. I'm on the meeting in a couple ways. I'm gonna leave from this screen, actually. Oh, I know why. I have too many screens open. I think I need to. Here it is. Sorry about that. Now I got it.
Are you able to see my resources now?
Yes, now we see them.
Okay, great. So you never need to start from scratch. There's a lot of resources that have been done. But if you see something in here that you feel that you would like to use in class and we need to tailor it, let's work together to tailor it. I think there's some possibility, like Jessica said, to do some things that we could tailor to our community, our Indigenous community. And I say ours because I'm Apache, and I think it's important to do that. To show our students of color and our Indigenous community that there is a scientist in their field, and we're there to support them as much as possible. So there is so many resources. Like I said, we will share these slides with you, that anyone can click on them, kind of search through. If you get lost, you can reach out to both of us, or Jessica or myself at any time, so we can do something. I think we're looking at doing a session in 2013, also at SkySong too. I know we have a teachers, what was it, a summer teachers program, Jessica?
Oh, yes. Oh, we do. So we have research experience for teachers. So and for undergraduate students, we're working on something for high school students next summer in 2023. So if we do, and when it's time, I'll send those links out to the group. Kimberly, if you could help with that, the application process, it is utmost important for us to have representation. And it is a priority from National Science Foundation, who funds us. So it's typically, we just need to connect with the right people, but we pay stipends for both of those experiences. I think the teacher stipend is about $6,000 for 5 weeks, and the student stipend, I'd have to look up. I think it's a little bit more because it's 9 weeks. The last year, and I think this coming summer, the student experience is actually at NAU, and housing is included, and they have the opportunity to work and do a research project with the Mira group, which is a fantastic husband and wife team up at NAU that have a focus on diversity and STEM, with material science and quantum computing and quite a few different areas. And the focus is to get students that don't attend NAU or ASU, so community college in particular, and give them the opportunity to be on a university research campus and do some research in an area they're interested in.
Yeah, thank you for that. And I think also maybe Kimberly and Katie is something that for the summer, for the teachers research, maybe if there's a possibility to look at an Indigenous curriculum at that time. I don't know, maybe Jessica and I will have to come together to see, or, I think that would be great. I don't know, Jessica, that's something probably we'll need to talk offline. Yeah. So here's the resources, and we'll download these slides and the references that we use. So if you have any questions, please feel free to reach out to us. Jessica, would you like to add anything else?
Just thank you so much for giving us this opportunity. We are available, me in particular, I am available to do this kind of experience for classroom or for teacher professional development, or even for an after school. We do some STEM after school activities to kind of bring awareness to this field. So thank you so much for having us today. We appreciate your participation and your engagement.
Well, thank you so much, ladies, for bringing that presentation to our awareness. Like I said, I learned a lot, and science has always been interesting to me, but I've never been great at it. But you know, there's never, you always learn what is it? You learn something new every day. So
Yeah.
that's really, really wonderful. I did have a question for the students. For next year or in the summertime, do they need to be in Arizona, or is it open to all students across the nation?
Yep, across the United States. And in fact, you know, there's some thought and encouragement to move students around. So for example, Penn State has an REU program as well, and there's 16 different universities that are part of this grant, and they all offer summer REUs. And we try to encourage some travel, especially for students that maybe have not traveled outside of their home state ever, or in particular for an extended period of time. So it is not required that they're an Arizona student, and we can definitely, when it comes time to recruit, we typically open up the application around January, and we try to have our final push by mid-March so that the students have plenty of time to plan. I would love it if you would be willing to, at that time, you know, accept our flyer and help really promote. We do have an interest and a commitment to bring more opportunities to Indigenous students and Native American students. And it's merely a lack of awareness, I think, on students' part, and making sure that we are doing everything we can, again, to be sensitive and accommodating as well to students' cultures.
Absolutely. If you send a flyer on over, we'll definitely get it out to our membership, as well as, of course, AIEA consists of a lot of educators, so we can just shoot it out to all of our students across the state. So definitely send some information, and when the flyer becomes available, we'll be more than happy then to share that out. And so
Wonderful.
thank you so much.
Are you open for like student campus visits? We have a program with our high school where we bring students out, and I think, you know, this would be definitely an eye opener for them.
It's my favorite. I was really sad, you know, during the pandemic, there wasn't this much opportunity. So I love organizing campus tours. So we have a lot of the work that's done in the technology space is done in what we call our nano fabrication labs. And so we don't necessarily take students into the lab, but we have a walking tour to go outside the lab. Which is really interesting to show, since they can see the scientists working in there. It's very similar to what you might have in fabrication plant, like at an Intel large company. And so we do that. We do take them into some labs where we might have a profilometer, which gives you that profile, right? Think topographic map. We have some machines that can show students how they image there. We take them into where we see an SEM, and we get some of our lab managers, we take them into the particle accelerator space so they can kind of see what a research lab looks like. And then oftentimes pop into some other disciplines outside of material science as well, to make sure that it's well worth your while to make the trip here on campus. But lab tours are really fun. We have some virtual field trip opportunities as well. One is a VR, and I can send you the link, Kimberly, if you could share it out with others. It kind of takes you into the clean room through a virtual reality space. It is something, it's a split screen. And so if you don't have the VR glasses, it's a little bit tricky because you see two, but when you put a VR headset on, you can go into the room and see the different bays and the equipment up close.
Kimberly put her email in there.
I'm going to copy it right now, Kimberly, and I'm going to send you an email so that you at least have my contact information.
Well, this is really exciting. And like Katie mentioned, you know, our students love to go on field trips. And this would be something I think would really catch their attention. And, you know, not only just catching their attention, but they're learning also at the same time. And, you know, I'm excited about it, and I'm looking forward to collaborating with you guys. And if there's anything we can do from our end as AIEA to help and assist, you know, we'd be more than willing to help out, especially with what you mentioned, Anna, with the collaboration for working on a cultural curriculum for the teacher
Yeah.
workshops. I think that would be absolutely wonderful. And I
Yeah.
think it would just be as an educational resource for even the non-native teachers that are out there on how they can implement this into the classroom, was what we're really pushing for.
Mhm. Yeah, yeah, yeah. I'll bring that. Jessica and I will bring that to the PI and see if that's a possibility. That would be wonderful. Yeah.
Absolutely.
Yeah.
Well, thank you.
Well, thank you both for staying on and being part of it. Yeah, we love it. And I will send the slides, and you know, you'll have both of our email addresses in case you need to reach out.
Sounds good. Katie, did you have any last thoughts you wanted to share out?
Well, this is just kind of funny, but so our biology teacher gave the assignment, if you were going to, you know, commit a murder, what, you know, after visiting the site, what things, you know, would you avoid? So, you know, you kind of like sneak around the kind of back door. So it was just an odd assignment, but everybody participated.
Forensics, I know, it's so interesting. And
Yeah.
so like little ways that we could support that is if ahead of time we discuss and plan, what might students say, or even, you know, if you have, we could probably find some answers. Like what are they likely gonna put down? Fingerprints, you know, we could get some fingerprints. And what's really cool is if you can get your students to actually do it. So like before the lesson, you could say, okay, I'm not going to tell you why, but I need 2 volunteers to come up. I need your fingerprints. And then you mail them to me. I need 2 people to come up and give me a string. I need a string. Anyone look around. You have a random string. I probably have one on my shirt right now I could cut off, right? So something from clothing. And you really get that student participation. And then as long as we prepare ahead of time, it's just mailing, you know, just mail it. And then we tell them, remember we asked you to do this? Well, what do you think? And you can have students sketch out what might it look like. And then we could image them and pull them up and then give them the remote access and have them take a snapshot. And they can even use that camera feature, and I can email the pictures back to them, and they could do a reflection where they include their photos. Those are the experiences, you know, that students remember.
That's
Yeah.
cool.
So I was, you know, thinking instead of, you know, saying committing one, instead, how would you help solve one? I think that would be my main change.
Yeah.
Absolutely.
Yeah, because the students would be focused on how to commit one than how to solve one. Yeah. Thank you for
Oh,
sharing
wow.
that.
Yeah. Well, thank you so much, Jessica and Anna, for bringing this very interesting presentation to AIEA. As I mentioned, this is recording, so I'm sure those who weren't able to attend will really enjoy watching the recording that will be uploaded. And so we do upload all of our recordings to our YouTube page for the Arizona Indian Education Association. So if you get a chance, let me drop all of our, it's actually on the agenda also, that I put up there at the very top when I send the agendas out, but I'll put it here in the chat so that y'all can grab that. But that's
Very good.
our email, our website, our social media, Facebook page, as well as our YouTube channel. And so we provide a lot of information and get information out that way. So as mentioned, once you get the flyer, we'll share it on all these sites. So that way we'll get that out for the awareness of what's coming up. And so I didn't know if you wanted to have any final thoughts about what you presented on.
I have one more ask. We had talked about, and you can let us know what you think about this. We had talked about taking a screenshot and including this interaction in our newsletter. What that might do is, again, I mentioned that there's 16 sites. What we've been trying to do is show what we're doing here with our community in Arizona to those other sites. We make a newsletter and then talk about how we engage the community. This might be a really important engagement opportunity that we want to include, you know, our other 15, 16 sites to create similar opportunities in their own communities. So if you're comfortable with it, we could take a screenshot and then kind of make a little summary of even just us on Zoom. I might put the electron microscope image back up instead of me as our main, but then we can kind of share, and we can send the text to you ahead of time to make sure it meets your approval. We could even promote, you know, your YouTube channel so that other communities can see how you're communicating with educators and sharing resources. Does that sound okay?
Absolutely, I would be fine with that. Katie, are you okay with that?
Yeah.
And I don't know if you have ability to show your video.
I'm gonna, let's see, now I got to put on my correct screen. I'm almost there. I'm sharing my screen, but it's just my, oh, wrong one. Again, I have too many computers open. Okay, let me get here. Now we're there. Okay, I'm going to do a quick autofocus. I like us right here.
Katie, are you able to share your screen, your video, or no?
Yes, the little flap was down. I thought it was up this whole time.
I love the background.
I know. Don't you wish I was just on a beach somewhere on a Friday?
Oh, love it. That's a front, right? I've got those are palm trees, of course. Okay. Now I'm going to take a screenshot. Actually, I'm going to move our images on top of this because I may end up cropping us. Let's stick us over here. I'm going to take a quick screenshot. Cheese. Okay. I'm going to make sure just that I have at least one real fast. I think I have to go to Microsoft Word. Let me try it this way. I'll send you all the. Yeah, there we are. I got at least one. Okay. Send it to myself. We're good.
Thank you.
Awesome. Thank you, ladies.
Thank you to everything, and we look forward to seeing you again and working and
Absolutely.
collaborating. Yeah.
Absolutely. And
Yes.
possibly even bring in another PD, maybe in person next time. We talk
Yes.
back to in person, so it'd be great. And any resources you would be able to share with us at that time, we would appreciate that too. If you need to send it ahead of time, you know, just let us know. We have members that are in the Phoenix area who can pick up easily also, so that, oh, this was really a great professional development training and workshop. So thank you, Anna and Jessica, again, for taking the time to share with us and to even show us the activities. My leg's still tingling. No, I'm just kidding.
Sorry.
That was a lot of fun. It just makes you rethink on, you know, getting into that mindset, you know, how did it happen and the reason for why it is the way it is. And so thank you for sharing that. And the activities, the interaction was great. So, you know, it was just overall a really great and wonderful presentation. So thank you, ladies, for presenting to us, and we will get this out to our memberships. And if there's any questions that come up, we will definitely reach out to you guys and forward that to you. So
Great. Thank you. I appreciate it. Have a great day.
Thanks for hanging with us on a Friday afternoon.
Yeah.
That was very nice.
Absolutely. Yes.
Yeah.
Thank you, Katie.
Bye.
Have a good
Bye.
afternoon.